topics are the structure of an atom, atomic number, and atomic mass number. So if you haven't watched those videos first, I'd start there and then come back and watch this one. So the deal with isotopes is that these are atoms of the same type, but they have different numbers of neutrons. And I've got a picture here that I found of hydrogen and helium. And let's just take a look at the hydrogen first. These red balls are my number of protons. So notice that in each case, I have one proton. We know that the number of protons tells me the identity of the atom. So all of these molecules, getting ahead of myself there, all of these atoms that we're looking at have one proton, so they are all hydrogen. The green balls are neutrons. Those are neutrons. And so what we see here is that we have one atom with no neutrons, one atom with one neutron, and one atom with two neutrons. They're all the same type of atom, but they have different mass numbers, because remember, your mass number is equal to your protons plus your neutrons. So in one case, we have a mass number of 1, 2, or 3. All of these are hydrogen. They have different mass numbers, so they are different isotopes of hydrogen. Same deal down here with helium and lithium. Let's take, for example, the lithium. In each case, we have 3 protons because it's lithium. In one case, we have also 3 neutrons, which gives me a mass number of 6. In the other case, I have 4 neutrons in the nucleus, which gives me a mass number of 7. Isotopes will have the same chemical properties, and generally they'll have the same physical properties unless the physical property is dependent on mass. For instance, density. The density of a particular isotope is going to be different than another because the mass that it takes up, or the mass that it has for a particular volume, will be different because the mass of the nucleus is different. We can take this information and produce something called an isotope symbol. And in an isotope symbol, we'll find the mass number written. You can kind of think of these as a big box, where we've got the element symbol, we'll call that E. We've got the mass number, that was A. The atomic number is written down here, that was Z. We've got the charge up in the upper right-hand corner. So if you're asked to do an isotope symbol, you need to make sure you include the symbol, the atomic number, the mass number, and if the atom is charged, i.e. if it's an ion, then you also need to include the charge. So sometimes the charge will be there and sometimes it won't, depending on whether you have a neutral atom or not. What is the isotope symbol of an atom which has 12 protons and 13 neutrons? So the 12 protons is going to tell me the identity of the atom, because protons tell me identity of atoms. The neutrons don't, right? We just illustrated the fact that my number of neutrons could be different, but I could still have the same type of atom. So 12 protons, I go to the periodic table, I am looking at the boxes on the periodic table where I'm remembering that the atomic number is written at the top above the element symbol. And I'm looking for number 12, and I find that that is magnesium. So there's my element symbol. I need the mass number to go on top. My mass number will equal my protons plus my neutrons, which equals 12 plus 13, which is 25. I always think of the big number goes on top. And then my number of protons is written down here. In this case, I don't have any information about electrons, and I'm told that it's an atom. So we can safely assume that it's neutral, and my isotope symbol is finished. Let's take a look at the type of question you might find on an in-class assessment. You'll notice on this table, we've got atomic number, mass number, number of protons, number of neutrons, and the isotope symbol. Once we start to talk about charges, those might be included as well, although I've left them off on this particular example. You might find that in your homework problems. We know that atomic number is the same as the number of protons. So if I have 52 as my atomic number, then I know I have 52 protons. My mass number we know is equal to our protons plus our neutrons. So if I know that I have 52 protons, then I can take my mass number and subtract 52, and that will give me my number of neutrons, which will be 77. My isotope symbol, I'm going to find element 52 because that's the number of protons I have. Element 52 is tellurium, and we have a mass number of 129 and an atomic number of 52. Now notice, when you look at your periodic table, the average atomic mass of tellurium is 127.60. At least that's what my periodic table tells me. That's different than this number that we came across in the example. Often these examples are made up. So you want to make sure that the mass number that you write down reflects the information that you're given in the problem, rather than the average atomic mass that you have on the periodic table. Because eventually we'll talk about average atomic mass and how it's different. But for now, just keep in mind you want to work with the information you've been given. Okay, in the next problem, I'm given the mass number and I'm given the number of neutrons. So if I take the mass number and I subtract the number of neutrons, then I should come up with my number of protons, which is 37. That will also be my atomic number. I'll look up element 37 on the periodic table. It's rubidium, Rb, and mass number goes on the top, atomic number goes down there on the bottom. No information about electrons, so we assume it's neutral. On the third one, I have 18 protons, so my atomic number is also 18. My number of neutrons is 23, so my mass number will be 18 plus 23, which is equal to 41. Element 18 is argon. Mass number is 41, and my atomic number is 18. And I've completed my